Thank you all for coming. I hope you're enjoying the conference so far. My name is Kat. I'm a software developer. I'm from Warsaw in Poland, hence my slightly different Twitter handle. I lived in Bristol in the UK for the last 10 years. And today I'm here to talk to you about optimizing the performance of your PHP apps. So as developers, when we are given a new task, or when we just want to start doing something, how do we go about this? So we usually like to start with planning, right? So if it's a bigger feature, or it's like a big task, or a completely new project, you might want to go off, do your agile planning, or whatever methodology you're following, do the sticky notes on the wall, or whatever your thing is. And even if it's just something small, you probably spend, at least a few minutes thinking how you're going to go about solving that, or how you're going to go about doing something. And then you write some code, and then hopefully you write some tests with the code. And then if the tests pass, then we're good to go to production, right? Well, where is performance in any of this? So some people do consider performance when they are coding, and that's really good. But most of us don't. And you can't really blame people for that, because analyzing performance is hard. It can be quite confusing to start with. And so I'm by no means an expert. I was in the same boat a few months ago when I was just told to optimize the performance or look at a performance of an app. And I was just like, where do I even start? So I thought it would be useful to share with you what I've learned so far and do a little demo of how you can go about optimizing performance. So hopefully you'll just seem a little less scary at the end of my talk. So let's start with the basics. Let's start with the why you should care about performance. I'm not going to spend too much time on this, because hopefully it's obvious to everybody. In case it's not obvious, how about this? Fast is better than slow. Duh, that's obvious, right? Memory efficient is good. Using less servers to run your apps is good, because you're saving money that way. Running out of memory in production is bad. And suddenly running out of memory in production is really bad. So that covers the whys. Maybe you're just forced one day. Maybe if you have some monitoring set up, maybe your graph looks like the one up here. So that's the memory over time. And you can see sort of the seesaw pattern, which is the GC doing its work, the garbage collector doing its work. But overall, that's creeping up over time. So that looks like a memory leak. Or maybe your graph looks like one of those at the bottom here. So this is a request time. And you can see that there is like a huge spike in here. So you might be wondering, well, why did it take so long? What was going on there? Or maybe you got our favorite PHP fatal error, allowed memory exhausted. We've all been there. So whatever your reason, you're probably likely to have to look into performance one day or another. Or maybe you just want to see what's inside the memory of your app, as it's running. Maybe you're curious what objects are in memory. What was it actually holding? So that covers the whys. In terms of when we should look at performance, well, we should be looking at it pretty much every stage of the software development lifecycle. So in development, when you're writing your app, you can start analyzing performance right there and then. You might have a dedicated load testing phase before you go to production with your app. And even after you've released your software, you should still keep an eye on things over time, because some of the issues only come out into the daylight over time. So to start with, you might not be aware that there is a memory leak, but over time, your graphs might actually show you that there is something going on. So you should keep an eye on it even after you're done coding. So now we know what, why, and when we should optimize. How about the what to optimize? So most of you probably have a pretty good idea of what to focus on. We usually just look at execution time, so the number of operations that we do, or we look at the memory usage and allocations. So that's sort of your general intuition. We generally want our apps to run faster and consume less memory. That's pretty obvious. We want the garbage collection pauses to be short and infrequent. We don't want the garbage collection to take ages. So we can measure things like execution time and memory usage. And you should probably think about establishing the minimum and maximum and average values for those. And your ops team or your DevOps people will love you for that kind of information. Because a lot of developers, they just sort of chuck their product at the ops team and they just go, can you deploy this? And then the ops team is going to go, well, what kind of instance does this need? How much memory are you expecting this program to need? And then people just go blank. They don't know. So it's useful to have that kind of information ready for your ops team, and they will love you for that. And, you know, like I said before, it might actually allow you to save some money because maybe you don't need like an extra large instance for your app, or maybe you're actually under provisioned or over provisioned. So it's a useful information to have anyway. But when I look at a performance, I like to start with this question. Because obviously doing something faster than you were doing it before is good, but not doing something in the first place, if you don't need to, is the best kind of optimization you can make. So I like to take the lazy approach, and before I even dive into something and start, you know, optimizing it and looking into it, I just like to take a step back and ask myself, well, is this something that I really need to do? Like maybe I can just do something once instead of multiple times. Or maybe I just don't need to do this at all. Maybe this is dead code. Maybe this isn't actually used. So this is something that a lot of people forget, and that's the best optimization you can do. So don't forget that. So this is my very unscientific graph to try and illustrate the goal of performance optimization. So we've got 3 axes here. We've got the memory and the time and the code. So obviously we want our programs to use as little memory as possible, to have just the code that we need, no dead code, and to be as fast as possible. So we're kind of aiming for that 0 point, that like unicorn point. But don't forget that very often when you're optimizing your code, when you're changing something, you might compromise the readability and the simplicity of your code. And that's something to keep in mind, because sometimes you go back to a code 6 months later and go, what is it even? Like, what does it do? Like, this makes no sense. And yeah, sure, it might be faster, but for your colleagues or for other people who might be working later on with you on the code, you're going to make their life difficult. So it's more of a balancing act. You kind of need to stop at the right point. So make your application good enough for production, but don't sacrifice the readability and the simplicity just for the sake of that. So don't necessarily aim for the unicorn. It's going to be somewhere in between. And don't necessarily expect to get to the unicorn as well. So when we think of potential issues that we might have in our PHP apps, that's a kind of list of the common ones that you might think of. So we might have our memory leaks, or maybe we're just consuming a bit more memory than we would like to. Maybe you've seen the graph creeping up over time. And maybe you've got some, if you're using buffers, maybe buffers are overflowing. Maybe you've got some unused references to variables that are still in memory, so the garbage collection can't clean that up because you're still holding them in memory. If you might run into timeout issues. If your program is, your program might be just stuck waiting on something and you just don't know what it's waiting for. If your program is concurrent, which you kind of have it in PHP sometimes, then you've got all the lovely issues that come with concurrency, such as race conditions and deadlocks and live logs and thread safety and all of those. You might have some redundancy and inefficiencies. I've kind of touched on that before. So you might be doing something more than once unnecessarily. You might have dead code or unused libraries, and you might think like, hang on a minute, that's not really that important, is it? But having unnecessary code in your artifact that you ship to production, it affects your build times, it affects your deployed times, so it does matter. And obviously, there is a whole load of server optimizations that you can do. So you can tune your Nginx or Apache config, tune your op cache settings and all of that. But I'm not going to touch on that today because that's a slightly different subject. We're going to focus on optimizing the code itself. So then when you start Googling, you find some pretty sane advice on the internet. You might find things like don't evaluate the condition of your loop inside your loop. So in here, that's the issue. So we're just looping from 0 to the end of the array, but we're actually counting the end of the array every time we loop we make an iteration through the for loop. So you should probably take that out in front of the loop and just do it once instead of all the time. And then the other one, a common one, is watching out for database queries that you could substitute with one big group query instead of one for every single ID. So especially in legacy code, when like your loops tend to be hundreds of lines long, and you might even forget that you're in a loop. So let's say one day you just want to, you're maybe fetching products from the database, and one day you decide that, oh, you also want to fetch an additional attributes of a product. And then you're inside the loop, so for every product ID that you have, you're going to go off to the database and fetch something for that product. Well, maybe instead you could take that query out of the loop, and instead of looping through the products and doing a query one by one, you can just do a group query. So for products for the product IDs in the range from X to Y, you can fetch all the attributes. So that's what that's about. And then you find things like, to check if the array is empty, should you use empty array instead of is the count of the array equal to 0. And then you should use the triple equal sign for string comparison instead of the string compare function, because it's faster. And then one of my favorites is use the single quotes instead of double quotes, because they are faster, unless you're concatenating variables. And then, you should use regex instead of some crazy, manual string manipulation, because regex is faster. But then don't use regex if you can use native string manipulation functions from PHP, because they are faster. So you're just like, so what? What do I do? And coming back to the list of issues, none of those actually help us to address any of those, right? On one hand, you don't ignore them, because sure, you might shave off some milliseconds here and there, and they are definitely valid points. But, especially if you're just trying to squeeze out the last bit of your performance juice out of the app, then yeah, those will matter as well. But is this really how we optimize performance in general, like in the bigger picture? And just to show you some stats, this is stats taken from Theomomatic's. He's got a website that runs PHP 5.3. It's quite an old website, but there's not that much difference between 5.3 and 7 from what I checked. So those stats are still pretty valid. And he basically just collected all those sort of micro optimizations and actually shows you what the difference actually is. So this is the single versus double quote myth. And you can see that, if you're not having PHP variables in it, they take the same amount of time, pretty much. I mean, there might be like microseconds of a difference, but rounded up to milliseconds, no difference. And if you're concatenating, so this is the double quotes, this is single quotes, you're only shaving off 2 milliseconds. I mean, that's a drop in the ocean. That's not really going to make your app suddenly fly. And then here's some other ones. So a lot of you might wonder, do I do the variable first, or do I do the constant first when I'm comparing? No difference at all. This is a string replace, and this is the regex replace. It's only 3 milliseconds of a difference. So yeah, regex is slower, but it's not really that much slower. What do those things have in common? Well, they're all micro optimizations, and they are worth it if you have the evidence that they are actually affecting the performance of your app. But 99% of the time, ignore them every time, I would say. Micro-optimize bits of your code. Like if you find that there is a bottleneck in your app, then yeah, sure, do everything you can to optimize that little bit of code. But try and not set off and try and optimize the entire app. So like set off and switch all the double quotes to all the single quotes across the entire app, because that's not really the way to go. Don't sacrifice the readability and maintainability of your code. So the thing that I touched on earlier, simplicity, readability of your code matters as well. And for the sake of 2 milliseconds, might not be worth it. And don't miss the real bottleneck. A lot of people just focus on the micro optimizations and sort of try and avoid tackling the real issue or the real bottleneck. So that's all well and good if you know then how to tackle that bottleneck. But the how is what most people get stuck on. And I got stuck on that as well. So how do you know what to improve? How do you find that out? How do you know how your app is doing in production? How do you gain that visibility into your app? How do you know what your app can handle in production? What are the limits? How do you know it's not leaking memory? Will you run out of memory? Maybe you won't, and maybe you don't need that extra large instance after all. And how do you prove your guesses? You might have a hunch that, oh, I think that's the slow bit, but how do you prove that? So the general advice is, of course, measure. But then how do you measure? And what do you measure? And how often do you measure? So I was there myself, and I had all those questions, and I was really confused at the beginning. So I thought it would be useful to do a practical example of how you might go about optimizing an app. So let's start with the tools. That's potentially the first confusing and the first overwhelming thing that you're going to come across, especially when you're starting out. Like, you just get told by everybody, oh, use this, use that, and then you're just like, well, but like, what is everything for? So this is kind of a classification, if you like, of the tools, like a grouping of the tools that I like to use when I come across a new one, and I just go like, oh, so what is this one for? So most of them are for monitoring your apps. So it's things like just keeping an eye on things. It could be logs, it could be request times, it could be the HTTP status codes, it could be CPU usage, it could be the uptime of your app, those kind of things. And they will generally give you the bigger picture, so like how your app is doing in general, but they won't really tell you what's going on inside as much. And you might be able to tell from those if there's anything to worry about. Like if your graphs are all flat and not looking pretty high anywhere, then that's probably a good sign. And then all of those, you can obviously set up monitoring for your development, but most of them are used in production. So if your app is actually not yet in production, maybe you're just starting out, maybe it's still only in development, then you can use the load testing and benchmarking tools to simulate load, basically, that you would have on production otherwise. And there is about 1 million of them. There is one written for every language and every framework under the sun. This is just a short list of the ones that I tend to use. The first 3, these ones are written in Golang, but you can use them with any app. It's just that the app itself is written in Go. GoWork is really easy to use. And then there is some, the ones that are sort of wildly known in the industry, especially in like performance testing. So there's JMeter, there is Gatling and Taurus, Apache Bench. They are slightly more complicated to set up, like the learning curve is a lot steeper, but they are also a lot more customizable and a lot more flexible. So they will let you do things like vary the load. So instead of just with the simple tools, you can specify, oh, I want to make 10,000 requests in 30 seconds. With the more advanced tools, you can actually vary the load a bit and go, okay, so just simulate like real world usage. So maybe fluctuate the amount of requests a bit. And then, you might just want to stick in a really big loop in your code. I mean, that's the simplest one you can have. And then, but all those things will kind of let you gain the bigger picture. But they won't really tell you what's going on inside your app. So to actually find out what's going on inside, you need things like stack traces and call graphs, and maybe the memory contents, maybe the memory dumps. So for that, you need a profiler, a tool called a profiler. And then usually the profiling data is not very human readable or human friendly. So usually you need some visualization tools on top of that to then help you make sense out of all the profiling data. So there are a few really good solutions available off the shelf. The most commonly used ones, I think, these days is Blackfire, one of our sponsors as well. So thank you. So Blackfire kind of gives you everything in one. It gives you everything from monitoring to alerting to profiling. Datadog and New Relic are more on the monitoring side, in my opinion. So they kind of give you a generic breakdown of like this request spent this much time in the database and this much time in the PHP layer and this much time in the JS layer, but they won't actually let you dig any further than that. And obviously all 3 of them you can set up alerting, so like if your request starts to take longer than this on average, then you get pinged. So that's really useful as well. And then there's the classic elk stack, which it's kind of more of a DIY solution. So you can do things like look at your access logs, which also log you the request time and the HTTP status code. And you might want to aggregate those and get some kind of information based on the logs. Graphite is basically a data aggregating tool. So you just basically chuck some data at it. And then it's really powerful when it comes to data manipulation and transformation, because it lets you produce graphs and do lots of crazy maths on the data that you have. So again, it's better than nothing, I would say. You might want to get some data out of that, but it's a lot more DIY. It's a lot more manual. So those top 3 is probably the way to go. If for example, you can afford it, or if your app is already out in production. A lot of people just tell, when I tell them about the things that I'm going to tell you later on about, then people just go like, oh, why don't you just use Blackfire? I'm like, yeah, well, that's all well and good, and it's a really great product, but what if my app is not in production yet? What if I don't want to go to the internet with it yet? What if my company, doesn't have the budget for it? What if it's just too simple? Like, what if my app just doesn't actually need any of the big off-the-shelf things? So I'm not really going to tell you much more about those. If you want to get a demo of Blackfire, I'm sure Fabian will be happy to give you one. Do check them out, by all means. But we're going to focus on kind of doing that ourselves. So how does this look like for PHP if you didn't want to use the off-the-shelf tools? Well, I started out with performance optimization in Golang, which is the second language that I use quite a lot of work. And with Go ships with all the tools built in. It actually has a profiler, benchmarking, everything is built into the language, which is really great. And then I looked at PHP, and well, there is nothing built into the language. If you install PHP on your laptop, you just get PHP. You don't even get xdebug. You have to install it manually. So there's nothing built into the language as such. You could roll your own. The simplest one that you can use is just microtime. So you record the start time, the end time, subtract the two. That's good enough for like quick and dirty ones. And then there's PHP extensions. That's where all the hope lies. So luckily, you don't need much extension food to get started with them. A lot of people get scared and go like, oh, I don't know how to do that. This is just a quick recap for those of you who have never installed an extension before. The simplest way these days is just to use a package manager. So you use your brew, like homebrew or apt-get or yum or whatever your Linux flavor is. Just do that, install package name, boom, it should just work. The other one is parent peckle, so you can use the peckle install, and again, it should just work, the S words. Or you can compile from source, which is actually not as scary as it sounds. You can clone your extension, run phpis on it, and then you just do configure, make install, so the typical C way of doing things. And then you need to not forget to load your extension in the PHP ini file, because that's what is very easy to forget. And you're like, well, why do I not see it yet? So don't forget the ini file. The two first methods, they create the ini file for you, so you don't have to worry about it. So let's get ourselves a profiler set up. There's a bunch of them out there. APD used to be an extension used for profiling, but it's no longer maintained, so I've kind of crossed that out. The two most popular ones are xdebug and xhprof. So a lot of people wonder which one should I use, and is it just like one or the other, or what's the difference? So the story goes that on PHP 5, xdebug didn't actually have memory profiling built into it. So it was great for your step debugging, code coverage, those kind of things, and it had time profiles, but it didn't have the memory ones. So for that, you had to use xhprof, so you kind of had to use both. xhprof was developed by Facebook back in the PHP 5 days, and then since then they've moved away from it because they're now on hack, so they don't have an interest in it anymore. But luckily, some kind people did PHP 7 forks of xhprof, so xhprof is still available in 7. The most popular ones are probably from the one from Tideways, which the caveat is that they actually don't ship with the HTML viewer anymore. So you get xhprof, but without the HTML like interface for it, which is a bit awkward. Or there is this Chinese person that I'm not going to try and pronounce the name because I'll probably butcher it, but that guy actually ported it right as it was on PHP 5 with the interface and everything. And yeah, other than that, they're pretty much the same. And then xdebug on 7 actually comes with memory profiling as well. So these days, you can probably get away with just using xdebug, but xhprof is still pretty handy sometimes. So I'll show you both. And then there's other completely separate things like the PHP memory profiler, another project on GitHub that you can install. It's just PHP extensions. And then meminfo, which shows you the memory contents. So we're going to have a look at meminfo as well later on. So when you start out, you kind of need to do your diagnostics before your diagnosis. So that kind of goes back to what I said before about proving your guesses. So your diagnosis might be your guess. So like, this is what's wrong. But to do that, you need to prove it. You need to actually have some proof, some measurements, to show that your guesses are not just guesses. So when I prepped this presentation, I sort of started out with looking for an example, and I didn't really want to do a foobar example because that's what everybody does, and that's not really how real life is. I mean, everybody can optimize a 5-long PHP app, but the reality is that sometimes you're just handed in an app that you might have not even written originally, and then just go optimize that, and you're like, well, I don't even know what this app does. So a while ago, a friend of mine, Branty, he just tweeted out about his new side project. He was like, oh, check out Cigar, my new side project. I'm like, ooh, what's that? So I had a look at the code, and it was the most beautiful PHP 7 code I've seen. And it turned out to be like a simple command line up for checking a list of URLs. So you give it a list of URLs in a file, and then it would just come back to you saying, yeah, this one was 200 okay, this one was 200 okay, this one gave you a 404, but you expected 200. So you just you give it a list of URLs and the expected code and any contents that you expect to get back. And it actually makes the request to those URLs, and if they differ, then it flags them. So it's basically just like a simple app checking tool. It's basically like a smoke testing tool for your apps or your APIs or whatever. So based on what I've told you so far, you know it's going to make some calls to the internet. So it's going to make some external calls. And I'm kind of deliberately not going into more detail here because that's, again, what real life very often is. Like, very often you just don't have a full picture of what the app is doing. You just have a rough idea of what it's about. So this is where we're going to stop. So imagine the first scenario. Somebody comes to you one day and goes, the app is running slowly. So they kind of come back to you with this. This is an example output of the app. So you just run it as a normal binary. But somebody says like, oh, it takes like 3 seconds. It used to take 0.3 seconds. Something's wrong. So at this point, you just go, well, okay, let's have a look. So the first thing we can do is we can set up xhprof for it. And the very important thing as well is to record the initial time somewhere as your sort of reference benchmark. Because later on, when you do your optimization and you go, okay, now it runs in like a second and a half, very often you forget what it was before. So you actually don't have the reference to go back to. So yeah, don't forget to actually record the initial time as your reference. So how do we go about setting up xhprof? There's a lot of code here, but don't worry about it. It's all on the README. You basically just copy and paste 2 bits, one at the start of the file here and one at the end. You can like include them in separate files. You can do the auto-prepend and auto-append file PHP ini directives to do that for you. You can just enclose a little bit of the code that you want, or you can just enclose the entire app. It's entirely up to you. But that's essentially all you need to do to set it up. You basically just give it a bunch of information, such as where to save the profiling data. And then so once you've got it set up, so once you've got the extension installed and once you've got the bits of code pasted in, then you can head over to the index file of xhprof, and this is the interface that you land on. So we can see here that there is some Branty cigar namespace things popping up quite close to the top. So there is this parse and get URL objects and a closure quite close to the top, and they are all taking over 2 million milliseconds to run. So we record the baseline, just over 3 seconds. And so this immediately kind of gives us the suspects. It points you like at the area of the code that seems to be running slowly. Except for we don't actually know what the closure is, and closures are really hard to optimize because very often if you have more than one in a file, you don't actually know which one it is. So, but this is good because we now have an area of the app to zoom into. And then what else you can do? So on the previous slide, you can view a call graph here. So if you click on that one, you get something like this. And you can't really tell what's inside the code, but it shows you the same thing. So this red box just says the closure thing again, and it tells you how long it took. So at least we now know what to look at. So how do we find out what's going on inside? What's inside that closure? Well, you look at the code, obviously, at this point. But let's use xdebug. So xdebug is, again, an extension that you install. And then you need to just chuck in a few things in your xdebug ini file. Again, that's all in the README, so you don't have to worry about getting this now. And then when you install xdebug and when it runs, it just saves the data, and then you need to view the data somehow. And xdebug output is not really human-friendly, so you can't just look at the files. So one of the most popular viewers for xdebug information is this thing called qcachegrind for Mac or kcachegrind for Linux. And that application kind of looks like it's from 1995 still, but it's still to this day like one of the most popular tools to view the xdebug info. So luckily these days it's pretty easy to install. On the Mac you just do brew install qcachegrind. This bit here, don't worry about it for now. It's on the slides, and I've already shared the slides, so you can have a look at that if you wanted to. You do need to do a bit of a workaround to get it working on the latest Mac OS, because it doesn't work out of the box with brew. But yeah, there's a workaround. You can get it installed pretty easily. There are also paid alternatives to qcachegrind. There's some bits on the App Store that I've seen, but they're like $30+ for an app, and they're pretty much equivalent to the free qcachegrind. There's also something called WebGrind, which is a similar thing. So when you open it up, so this is the output file from xdebug. I've just told it to save it as cachegrind out whatever random string. There's this drop down here. This is time or memory, so we're going to set it to time for now. And when we zoom in, we see the same things. So at the top, we see the same namespace with the same bits, so the same functions that it's pointing us to. So there's this parser class that keeps coming up. And then on the right, you can see something called it's like a pyramid graph. I think that's the name for it. And that's basically a color graph. And a lot of people immediately just like think that a lot of tiny boxes stacked on each other means that that's the busy part. It's actually the opposite. So what you're looking for is the giant squares which have nothing else on them, because that means that proportionally this green box took a lot of time to run, but it didn't actually call anything subsequently. So the little boxes is basically just lots of calls stacked on top of each other, but the calls might have only taken like a second each. So that doesn't actually mean that there's a problem there. Yeah, big empty squares is where the problem usually lies. So when you hover over the green box, it's the same thing, the parser class, the get URL, and the parse method. So we've confirmed now xdebug and xhprof agree on what seems to be the problem. And then in qcachegrind, you can also see the call graph. So we've got again the parser class, and this is the closure box. So you just click on the call graph drop down here. And then just to show you the comparison, it just comes out with pretty much the same call graphs. They just look slightly different, but they highlight the same things. And they both indicate that parse took around 80%. This is 2 separate runs. So I've run the app once with xhprof and once with xdebug, so that's why it slightly differs, but they seem to agree. So what else can we get from that? Well, we can see that when we look at the functions in qcachegrind, the top ones, we can see this array map function, native PHP function. But we might want to wonder what's calling it. Like, why is it at the top so high? And it also gives you the call, the number of times it was called, and the cumulative time. So you can click on the callee tab, and again, you can see the closure here. So you can see that this was called by the closure. And then the cool thing you can do here is you can actually view the source code directly. So when we view the source code for that closure, well, we can see this like weird return array map, which is what we were pointed at, with $pi = 4. So I wonder if maybe for the purposes of this demo and to make that function slow, somebody has stuck in a pi calculating function, which is really inefficient. Yeah. Brunty didn't actually do that in this code. I did that just to make it run slow. So this is inside the get URL objects function, which again, what we were pointed at before. So then again, we remove the pi code, and surprise, surprise, we're back to 0.3 here. So we've kind of proven that by removing that and zooming in, we brought the time back down to what it was originally. And then when we run the xhprof again, we can see that parse is, so this is the top. Parse is no longer at the top. It's somewhere here at the bottom with just 723 milliseconds as opposed to over 2 million beforehand. And then when you compare the call graphs, this is the before, this is after. Parse doesn't even show in the call graph anymore. The red box, if you zoom in, that's now guzzle functions. So guzzle HTTP. But then again, knowing about the app and knowing that it makes external requests, you kind of expect that. You kind of expect to see that. So this is not alarming anymore. Even though xhprof makes it look red, you can kind of assume that this is just normal operations. So one important point to make here is as well, if you see some library code or if you see native PHP functions, don't ignore them just because, oh, it's a library, so I don't need to worry about it. Libraries also come with memory leaks. Libraries also might have problems. So if your call graphs or if your profiling information is pointing at a library, by all means look at it. Like we've had a case at work where one of the metrics libraries that we used in a Go app, that had a memory leak that affected our apps. So don't ignore the libraries or frameworks just because they're like third-party code. They also come with problems. So then we look at qcachegrind again after removing that PyCode. And again, we don't see the parse at the top. We see guzzle HTTP here. So yeah, nothing at the top. It's just guzzle here. And then the pyramid graph looks different as well. And now we've got curl multi-select here, which again is just internal calls, making the calls to the URLs. So that was kind of a good first step, right? This is like, okay, we've done something, we found out what the problem was, we removed the problem, got it back to 0.3. And by the way, you can also view xdebug information in PHP Storm if you use it. It's kind of a work in progress still. For PHP 7.2, I had to install the EAP version of PHP Storm because it didn't actually quite work with 7.2 yet. They might have fixed it since then. But yeah, you basically go to Tools and then Analyze xdebug profiler snapshot, and you can get the cumulative times and the same kind of list of functions. And then you can also click on the call tree, and that doesn't actually give you the call graph, but it gives you the typical PHP Storm drop-down things where you can like click and drill down. So it is pretty useful still, but not as powerful as qcachegrind. So what more can we get from xdebug output? Well, you can see how many times a function was called. So this one, we can see the string to lower was called 123 times. And then you can see at the callers list. So you can actually, it tells you what calls the string to lower. So you can see some guzzle things. And you can see that it's a lot of header-related functions. So you can kind of get the idea that maybe guzzle is lowercasing all the headers. So where this is useful is that it actually gives you an idea of what your app is doing. Even if you don't know the code exactly, maybe you didn't write it, but you can kind of get a good idea of what's going on inside your app. And then what else can we see? Well, we see fopen called 9 times. And you can see here that 2 of them are coming up under guzzle, and one of them is our parser one. And well, we would kind of assume that our cigar app only does it once to open up the list of URLs to check. So what the hell is guzzle doing with fopen? So maybe we can look at the source code, and yep, for the guzzle one, it's actually writing something to PHP temp. So some temporary information is actually stored on your disk from guzzle. So you can really dig deep into like understanding what the code actually does. So let's flip the drop down here to memory now to get the memory information. And we've got this get file contents function, which is reading the file and reading the list of URLs. So it uses fopen too, we know that. And then we can click on the callers tab. And we can see here it uses fread, fopen, and then file size. And that kind of agrees with what the source code actually is. And at that point, you might be wondering, well, because we know that we're only reading from that file, there is also a file get contents function in PHP. So you might be wondering, well, is that faster? And sure enough, if you swap it for the file get contents function instead, then you get a slight optimization. It was 512 before, so this is memory per call. So 512 bytes versus 496 bytes. So this is obviously a tiny little thing, and that probably won't really matter in the bigger picture. But it just shows you that if you're ever wondering, like, oh, is this function faster than this one, then you can just easily experiment with that and prove your guesses with xdebug. And you literally just need to say, so you run it once with the before functions, then you swap your functions, you run your program again, you get a new xdebug profile, you just open that up in qcache_grind, and there's your comparison. So it's a really quick feedback loop as well. It's all local. You don't need to wait minutes for the profiling info or anything like that. And xhprof actually doesn't show you any of this. So if you click on the get file contents link, so you kind of click through the links in the interface, that's as far as it goes. Doesn't go any further. It doesn't actually zoom into the code itself. And then the call graph as well. It just shows you the parse function and the get file contents function, but it doesn't actually show you anything beyond that. So xhprof is just probably not very helpful in this case. And that's why it's good to use more than one tool, essentially, and familiarize yourself with as many as you want, because sometimes one might show you something that the other won't. So what if you want to just do some general exploration? How do you check, for example, that your program is not leaking memory or what's inside your memory? You can obviously look at the memory numbers in xdebug or xhprof and compare them over time. You can watch your monitoring graphs. If it looks like something like this, that's actually pretty good, because the line here is pretty steady. It doesn't increase. That's just GC doing its job, so that's fine. But it would be nice to, for example, have a look inside the memory and actually see, well, what's inside the memory when we run our app. So for that, we can use the php meminfo extension. Again, you just stick one line in it. That's all in the README as well. You pretty much just tell it where to look for the JSON file that it saves. And that actually outputs information in JSON, which is slightly more human-friendly. But again, it comes with its own viewer. So you can use the meminfo analyzer to then analyze the profile. And that's very useful for spotting objects that maybe shouldn't be in memory. So here you just do the summary call, and you can see that there is a parser object, an outputter. There's some strings, arrays. It gives you the count. So we have 44 strings in the memory at the point at which the profiling ended. We've got some floats. And for the sake of the demonstration, let's just look at this parser object again. If you look at the source code in the main cigar file, you create the new object, and then you just use it to parse the file. And then you use it. You don't use it afterwards. You just only call it once. But it's somehow still in the memory at the end of your run. So it looks like we're creating that variable, and then it just stays with us. Maybe the GC doesn't get to it. Maybe the program is just too short. But maybe there is some kind of reference to it that we're still holding. So you can actually do the query call for the analyzer and zoom into the object exactly. So it gives you the ID, how it's stored in memory. It tells you the class, it's an object, the size, it's the root object, so it's not a child object or anything, and then the symbol name. And then the execution frame is global, so that's the global scope. So let's dig deeper. You can do the refpath call and give it the ID of the object, and it gives you the references to that object from memory. So here is a self-reference. So this is the same object, which is normal in PHP. Every object has a reference to itself. And then you can also see the global scope. That also holds the reference to the parser object, which is kind of what you'd expect, because that file is the procedural file in the global scope. So in this case, it's obviously fairly harmless. Like, there's nothing suspicious in here. But you could have had an object which has tons of references that you just wouldn't expect there to be. And out of curiosity, you can look up the global's ID. So you can just pass the query with the global's ID namespace instead. And you can see some familiar things. So you've got the gets and the posts and the cookies and the files and the requests and the server. That's all in the global scope. That's where PHP holds all that information. So can we make that parser object go away somehow? We know we don't need it once we're done reading from the file. We can just get rid of it. So in PHP, you can also do this. You can just create the object on the fly and then call parse on it. And then you might be wondering, well, is that maybe any better if we're not saving it in a variable? So then we run the analyzer again once you change the code. And yeah, sure enough, it's gone. So again, you've got your hard proof here that you've optimized something. You can prove that it's no longer in memory. So just to make it clear again, none of those things were in Brunty's original code. I've just modified it to make it horrible on purpose. So yeah, hopefully it was useful to see this. There are many more tools out there, but literally xdebug and xhprof are the main two things to use. It might seem a bit tedious at times. I mean, sometimes you spend days digging into something and you're still none the wiser. But it's really worth it in the end. Like the feeling that you get once you optimize something and you can see that you brought it down from like 5 seconds to 2 seconds, it's really worthwhile. So just to sum up, some key takeaways. First of all, prioritize what to focus on. Don't sweat the small stuff. Don't focus on the micro optimizations. Tackle the big things first. Basically, focus on the most important things. Sometimes when you're given something to optimize, you only have a specific time frame. So don't waste time on the things that don't actually give you much gain. Just focus on the bottlenecks. Customize the optimization for your needs. Like sometimes doing something in maybe not the most elegant way or not the most elegant code might actually be faster. So it's kind of like with database denormalizations. Like don't be afraid to do it if it actually serves your purpose. Measure. Use the data to prove your guesses. Don't just guess. Trying to do it with minimal impact on performance. So xdebug, never run it in production. xhprof has a small like memory footprint, so you can run that in production. Don't ever turn xdebug on. And don't forget that optimizing performance is an iterative process. So it's not enough to just do it once and then forget about it. You kind of have to come back to this over time and keep an eye on things over time. So have your monitoring in place, have some alerting based on the trends in your graphs. You can run automated load tests as well if you have that kind of setup to, again, just automatically check the times over time. And then for like the VIP experience, there was a really good Etsy blog post about how they correlated the graphs with performance versus deployment times. So actually, they have a graph that shows performance and then when they deployed code. So you can zoom in, so you know exactly at what point something maybe got worse. So that's all I have. If you have any questions, I'm not sure if we have time. I'll be around, so feel free to just come and chat to me afterwards. And yeah, I hope you enjoyed the rest of the conference. Thank you.